Hello, everyone. Uh, as you might have noticed, the Quick Play, the software I'm using to record, my lecture, abruptly, dropped out of recording. So I was, the little panicked, but luckily, I was able to save, whatever, that was recorded. Right, so there's a little bit left here, so I'm going to finish that, right, in this lecture. In fact, it is my intention, it is my intention not to, try not to exceed, the more than 30 minutes, but, actually previous one has gotten pretty long. It was more than 1 hour. Anyway, this is going to be pretty short. Uh, Right. So this is where it was interrupted. So from this we see that x prime equals -7 and y prime equals 4 is a solution. Is a solution of uh, 39 x prime plus 69 y prime equals the greatest common divisor of 39 and 69, which is 3, right? And 1137 is 3 times, okay, so I gotta move to next page. So 1137 is 3 times 379, 379. So x equals 379 times x prime, which equals 379 times x prime was x prime was -7, right? X prime was -7. -7. So this should be x naught. Okay. So that's going to be -26, 53. Okay. And y naught equals 379 times y prime equals 379 times, I think it was 4, right? So y prime equals 4, and that equals 1516. This is a solution of solution of 39x plus 69y equals 1137. Thus, all solutions are x equals x naught negative 2653 plus b over d. Okay, b over d. So b equals 69, right? Divided by 3. That's the greatest common divisor of 39 and 69. So that's going to be 23. So 23d t. And y equals y naught 1516 minus a over d. A equals 39 divided by 3, that's 13, right? So negative 13t, where t is an arbitrary integer. So that's going to be all solutions. But that's not what we are looking for, okay? So, we require that since x and y, I think earlier I said the x and y have to be positive. That's not entirely correct, okay? Because there's a possibility that maybe he didn't buy any of the 39-cent pens, or maybe he didn't buy any of the 69-cent pens. Okay, so we have to include those possibilities as well. So actually, x and y are required to be non-negative integers. In other words, x is required to be greater than or equal to 0, and also y is required to be greater than or equal to 0. So t is in this case greater than or equal to 2653 divided by 23, and that equals 115.3478 and so on and so forth, right? So that means t is greater than or equal to 115.3478 and so on and so forth, right? And also from the condition that y has to be positive, we also have and we have t is also less than or equal to 1516 divided by 13, right? 13. And that's going to be 116.6153 and so on and so forth. Okay? So here, there is only one integer value for t which satisfies both, okay, both inequalities, right? Greater than or equal to 115.3478 and so on and so forth, less than or equal to 116.6153 and so on and so forth. I mean, you know what it is, right? X equals 116. I mean, t equals. So this implies t equals 116. So with this value, t equals 116, we have x equals negative 2653 plus 23 times 116, that equals 15, and y equals 1516 minus 13 times 116, which equals 8. Okay, so that there is only one solution. This means that the man bought 15 39-cent pence and 8.69 pence. Okay, so that's the solution to this example. Okay, so this is it. And more details of my discussion in this lecture can be found in my lecture note at the following address. As usual, it is hyperlinked. So all you have to do to get there is to click on this address, right? And also, if you want to visit my main blogger site where you can find lots of many other lecture notes in different subjects, just click on this word blogger, which is also hyperlinked. And number three, problem set two, right, which is about linear combinations, is available at the following address. Uh, Again, this is a hyperlink, so you just click on it and it'll take you there. Thank you very much for listening and watching my lecture. Bye bye.